Gyronics.
Okay, so this problem is quite challenging. An iron ball, 4 inches in diameter, weighs 9 pounds. Find the weight of an iron shell. So we have two objects, but the same material, which is iron, which means they have the same density. So the iron shell, 2 inches thick, whose external diameter is 20 inches. So first, let's visualize this first object, the iron ball. So we have an iron ball with 4 inches in diameter. This one weighs 9 pounds. Okay? The second object is an iron shell. So this one has diameter of 20 inches and thickness of 2 inches. Okay, so let's take a quick insight on this visual. So first, we have this outer diameter, which is 20 inches and thickness of 2. So which means this one is 2 inches, the left side. So to the right side, another 2 inches, which means the inner diameter is 20 minus 4 is 16 inches. So take note of that. Okay. So first, let's analyze the volume of a sphere. So refer to this sample sphere with radius r. So the volume of this sphere is, this is still area of base times height, but 2/3. So the idea behind here is, if the sphere, for example, is placed inside a cylinder, given or considering that the radius of the sphere and the base of the cylinder are equal, and the height of the cylinder is the diameter of the sphere, so this sphere will take 2/3 of the volume of cylinder. So volume equals 2/3. So of course, area of base is pi r squared. So this is the base of the cylinder times height. So what is the height? The height is the diameter of the sphere, which is twice the radius. So times 2r. Okay? So these two can be multiplied to the numerator, given as 4/3. So volume now equals 4/3 pi r cube. So where is this r cube came from? So this one, the r squared times r, that is r cube. Okay, so we'll be using this formula to the problem. So we have volume of sphere is 4/3 pi r cube. So let's calculate for the volume of the iron shell. Okay, so the volume of the iron shell is the volume of the outer sphere. So this one, the 20 inches diameter, minus the volume of the inner sphere, so the hollow region. Okay, so this will result for the volume of this shaded region only. So what is the radius of the outer sphere? Diameter is 20, half of that is, of course, 10 inches. And the next equation is, we have outer volume, 4/3 pi 10 cube, that is the radius of the outer sphere, minus the inner. So what is the radius of the inner sphere? So this is 10. And the thickness of this shaded region is 2 inches. So which means 10 minus 2 is 8. So that is the radius of the inner sphere. So we have minus 4/3 pi 8 cube. Okay, so the radius of the inner sphere is 8. This one, 10 is the outer sphere. We have common 4/3 pi, 4/3 pi. So we can simplify this further. The next equation is, we have 4/3 pi times 10 cube minus 8 cube. And this will give us the volume of the iron shell, which is 1952 pi over 3 cubic inches. Next, to calculate for the weight of this iron shell, we need the information given for the iron ball. So based on the problem, the iron ball has a 4 inches in diameter. So first, let's calculate the volume of this one. So of course, half of that is 2 inches. So that will be the radius. So we have the volume of the iron ball is 4/3 pi times 2 cube, which is 32 pi over 3 cubic inches. So this is the volume of the iron ball. And given to their problem, this iron ball weighs 9 pound, which means the density of this iron ball is, we have 9 pound per volume, which is 32 pi over 3 cubic inches. Density is mass over volume. Okay. Iron ball and iron shell have the same material, which means they will have the same density. And we calculated already the volume of the iron shell, which is 1952 pi over 3 cubic inches. So let's multiply this to the rate, which is the density. We have 9 pound per 32 pi over 3 cubic inches. Okay, so again, check the denominator. We have cubic inch. So these two cancels out. And this will give us the weight, which is 549 pound. So this is the final answer. Okay, so quite challenging problem, but I hope you can follow the step-by-step solution, and see you on the next exercise.